Glowing steam hisses from cracks in the sand, and fishermen report ocean water suddenly boiling as if from deep below. Something strange has awakened beneath the California beach. Exactly what the title warns, and just as unsettling as it sounds. Official maps show no volcano here, but new sensors are picking up signals that split the experts. Slight tremors map out what could be a hidden fault line, while chemical clues hint at magma on the move, unseen for generations. If it's a new fault, it could threaten millions with an earthquake. If it's magma, an uncharted volcano might be rising under the waves. So which one is it? And do we still have time to prepare? California's coast is more than just a meeting place for land and sea. It's where two massive plates of the Earth's crust grind past each other, constantly reshaping the shoreline in ways that are both subtle and spectacular. The Pacific Plate, moving northwest, drags against the North American Plate, and that friction carves out faults, uplifts hills, and triggers earthquakes from San Diego to Eureka. But there's another, quieter force at work offshore. Underwater volcanoes, some buried beneath miles of ocean, can push molten rock and heat upward, changing the chemistry and temperature of the water above. The axial seamount, sitting about 700 miles northwest of San Francisco, is the nearest active submarine volcano to the California coast. It's been swelling at a rate of up to 25 centimeters a year, almost an inch a month, according to pressure sensors and satellite measurements. Every few years, it erupts, releasing lava and gas, but you'd never see it from the beach. Instead, scientists track its movements through a web of underwater cables and instruments, watching for patterns that might echo closer to shore. William Chadwick, a leading researcher at Oregon State University, calls Axial a natural laboratory for eruption forecasting. He spent decades watching its inflation cycles, noting how the seafloor rises and falls as magma moves in and out. Chadwick explains, "The signals are there if you know how to listen. Pressure changes, heat, seismic tremor. It's like the volcano is breathing." These same kinds of signals, ground shaking, pulses of heat, strange gases, are now being picked up along the California coast, but the source isn't so obvious. Fault lines can mimic some of the same symptoms as magma on the move, especially when they shift suddenly or allow deep fluids to escape. That's why every new reading, every spike in temperature or rumble underground sends experts back to their maps and models, weighing the odds. Is the ground breaking from tectonic stress, or is something hotter and deeper forcing its way up? The answer may depend on how well we can read the hidden language of the Earth beneath our feet and just offshore. Long before sensors and viral videos, California's coast had a reputation for strange happenings that locals couldn't explain. In the 1790s, Spanish missionaries wrote in their diaries about columns of sulfurous vapor rising from the sea after tremors shook the ground. They described the air turning sharp and bitter, and the sand near the waterline growing too hot to stand on. Stories like these weren't just one-offs. The Chumash people, who lived along these shores for thousands of years, spoke of breathing sand and hot grounds that moved, warning children to stay away when the earth felt restless. These tales weren't just superstition, they were observations, passed down through generations, of a coastline that sometimes seemed alive. Fast forward to 1908, and a local newspaper in Los Angeles ran a headline about a mysterious fissure opening along the shore after a moderate earthquake. Witnesses reported rising mists and a rotten egg smell that lingered for days. The article described beachgoers watching as steam hissed from cracks in the rocks, unsure whether to run or stare. Even then, the cause was debated. Some blamed a hidden fault, others whispered about fire beneath the sea. Bill Cooper, whose family has lived near Portuguese Bend for decades, remembers hearing these stories from his grandfather. He'd say the land here has a memory. It breathes, it grumbles, and sometimes it lets you know you're not in charge. Today, as scientists puzzle over new steam vents and trembling ground, Cooper's words echo a deeper anxiety. Whatever is happening now, It's not the first time this coast has given off warnings no one could ignore. The pattern is long and unsettling, a reminder that the line between legend and lived experience can blur when the ground itself refuses to stay quiet. Time-lapse satellite imagery doesn't lie. In a series of frames captured over just a few months, the shoreline at Portuguese Bend transforms. What was open water in spring is suddenly capped by a new tongue of land by late summer. The change isn't subtle. Where fishermen once anchored boats, a pale, raw strip of earth now juts into the surf, still steaming in the morning chill. If you watch the Google Earth archive, you can pinpoint the weeks when the coast starts to bulge outward, the vegetation line pushed back as sand and clay rise from below. The water's edge redraws itself in real time, swallowing tide pools and leaving stranded kelp high and dry. No ordinary landslide moves this fast, and no seasonal storm could pile up so much ground. The satellite's infrared sensors pick up a new heat plume, glowing faintly but unmistakably, right where the steam vents first appeared. In one sequence, you can even see the pale discoloration spreading outward, a sign of freshly exposed minerals reacting with air and seawater. The shape of the coastline shifts, not over centuries, but between one set of images and the next. For scientists, this kind of visual evidence is a call to arms. When the land itself rewrites the map in less than a season, every agency from the USGS to local universities scrambles to get boots on the ground. The satellite record leaves no room for speculation. Something deep and powerful is forcing its way up, and the clock is ticking. The story moves from rumor and recollection into the hard, digital truth of the present. Now, the question isn't whether the ground is changing, but what's driving the transformation, and how much more is waiting beneath the surface. Inside the field tent, the debate is anything but academic. Two camps, same data, no agreement. On one side, you've got the fault line group. They're reading the seismometers and pointing to shallow, brittle snaps, classic earthquake signatures. The ground here, they argue, is acting like a loaded spring. When it slips, you get cracks, sudden uplift, and a burst of seismic noise. Their case rests on the shape of the coastline, the way the land lurches upward, and the absence of fresh, igneous rock at the surface. To them, this is a landslide in fast forward, powered by tectonic stress, not molten rock. But then, the magma camp steps up, waving printouts of gas readings and thermal scans. The steam venting from the new fissures is loaded with helium-3 and sulfur, chemicals that don't just drift up from old groundwater. The isotope ratios are off the charts, more like what you'd see at an active vent than a fault slip. Surface temperatures are spiking 20, sometimes 30 degrees above normal, and the air stings with the sharp tang of volcanic gas. They point to the satellite's heat plume and say, "No landslide cooks the ground like this." Slack threads fill up with arguments. Dr. S. Lawrence, caught between daily briefings, types out, "This looks like a slip event, but the chemistry says magma." That line gets repeated in every meeting, fueling the standoff. No one's ready to rule out either side. The instruments keep chirping, but there's no consensus, just a growing list of questions. With every new reading, the divide gets sharper. Until someone can prove otherwise, both earthquake and volcano warnings stay on the table. The coast waits, caught between two explanations, and no one's sure which risk to prepare for. No one's taking chances with guesswork. Every scientific team at Portuguese Bend brings their own forensic toolkit, each piece designed to cut through the confusion. The first step is always containment. Steam condensate traps, made from sterile glass or PTF E-lined steel, get lowered right into the vent. These aren't your average jars. They capture vapor straight from the source, sealing it tight before air can sneak in. For the bubbling water, Researchers invert rigid funnels and snap gas-tight bottles over the rising bubbles, grabbing samples that might hold the chemical fingerprint of magma, or just old groundwater. Down in the sand, stainless steel soil gas probes go deep, sometimes half a meter, pulling up pockets of gas for isotope analysis. Each vial is labeled, sealed, and rushed to a cooler, because even a few minutes of exposure can scramble the results. Portable multi-gas sensors and thermal cameras sweep the area, mapping where the heat and gases are strongest. Instruments like DOAS and FTIR, think of them as the bloodhounds of the field, scan for sulfur dioxide, hydrogen sulfide, and carbon dioxide, sniffing out concentrations that hint at volcanic processes. Inside the lab, the real detective work begins. Scientists run isotope ratios for helium and carbon, looking for numbers that match magmatic sources. Magma usually means a helium-3 to helium-4 ratio above 5, and a carbon isotope signature between -7 and -4 per mil. If the readings are lighter or the methane is too high, that points to biogenic or even man-made contamination, sewage, leaking pipes, or decaying organic matter. It's a race against time and error. Seawater dilutes everything, and coastal winds can blow in contaminants from miles away. Even a single fingerprint on the sample bottle can throw off the analysis. That's why every step, trap, probe, bottle, sensor, follows strict protocols. Only with this forensic arsenal can scientists hope to settle the argument. Is the ground breaking from tectonic stress, or is something deeper and hotter pushing up from below? Pressure doesn't just come from the ground. At Portuguese Bend, the science teams aren't the only ones with something at stake. Real estate developers and tourism boards have their own crisis response plans, and they move fast when the news cycle turns sour. Within hours of the first viral steam videos, emails fly between city officials and PR consultants, some urging reporters to use softer language, others asking scientists to hold back on the scarier data until the council can review it. The message is clear: don't spook the market. Drone flights over the beach are suddenly restricted. Officially, it's for public safety, but Bill Cooper, who's watched the coast change all his life, calls it what it is: damage control. They don't want buyers seeing the cracks, he says, waving at a strip of caution tape where the sand has split. Even university researchers get pushback. One team's request for high-resolution sensor data is denied, citing sensitive infrastructure. On the ground, the tension is thick. Cooper's neighbors worry about home values, but also about what they aren't being told. Last time something like this happened, they said it was nothing. Then the road caved in. In council meetings, talk of hazard zones and evacuation triggers is buried under slideshows of happy tourists and new condos. Behind closed doors, the city weighs the cost of an honest warning against the risk of panic. Science here isn't just about steam and sensors. It's about who gets to decide what's safe and when the truth is too expensive to say out loud. With every new restriction, the scientists' window to act shrinks, and the stakes for the whole coastline grow sharper. October 15th, 2025. The meeting isn't on any public calendar, but inside the county emergency office, the air is thick with urgency. Every seat is filled. USGS field leads, county officials, emergency managers, and a handful of scientists who haven't slept in days. Phones buzz. The latest seismic plot is projected on the wall, jagged with new spikes. On the table, a stack of gas analysis printouts, helium-3, sulfur, carbon isotopes, none of it lining up cleanly with the last round of tests. Some numbers look volcanic, some scream fault slip, and nobody's willing to bet the coastline on a single explanation. Dr. Meredith Gage, the USGS chief for coastal hazards, stands up. She's not one for speeches, but tonight, every word counts. "We don't have proof of a major eruption," she says, voice flat. "But these readings are outside the range of anything we've seen at Portuguese Bend. We need to monitor for volcanic hazards and prepare for earthquake impacts. Both." Around the table, heads nod. Some reluctantly, some with relief. The decision is made. Simultaneous hazard advisories go out. Earthquake readiness, volcanic monitoring. County emergency texts are drafted, social media warnings queued, local radio lined up for late-night broadcasts. No one leaves the room smiling. The cost of waiting is too high, but the price of panic could be higher still. That night, the coastline enters a new phase. Official alerts ripple through the community, reaching phones before sunrise. Scientists double-check every sensor. Residents scan the horizon for new steam. For the first time, the risk isn't just theoretical, it's on record, and everyone's watching for what comes next. Sensors never blink. Every minute, they log tremors, temperature, and gas readings, building a living record of the coastline's mood swings. The model for this kind of vigilance comes from the axial seamount, where round-the-clock data streams have already helped scientists predict eruptions with surprising accuracy. William Chadwick, who's watched axials cycle for decades, calls it a rare chance to test forecasting in real time. No guesswork, just signals and outcomes. He points out, we're finally seeing what a volcano looks like when it telegraphs its moves, and how that can help us prepare elsewhere. On the California coast, that same approach is now standard. Arrays of seismometers and gas monitors feed their numbers straight to university labs and emergency dashboards. Each spike or lull is a clue, maybe a warning, maybe just noise. The lesson from Axial is simple. Don't wait for disaster to confirm your suspicions. Keep watching, keep testing, and let the data tell the story, even when it's messy. Bill Cooper, the local who's seen generations come and go along Portuguese Bend, stands by the caution tape and shrugs. You can't outguess the ground. All you can do is pay attention. The future here isn't a clear path. It's a set of moving targets, each one shaped by what the sensors catch next. For now, the best anyone can do is stay ready, eyes open, and hope the next warning comes with enough time to act. Satellite imagery confirmed that, in less than 6 months, over 2 acres of new land appeared where surf once rolled. A change backed by sensor data showing both seismic pulses and unexplained heat. Historical records from the 1790s to 1908 describe similar, mysterious coastal disruptions, tying the present event to a centuries-long pattern. Scientific teams remain split. One side points to fault movement, the other to underground magma, but neither explanation fits all the facts. Documents from the October 15, 2025 advisory meeting show officials issued a dual hazard warning, earthquake and volcanic risk, while restricting full data release. Today, round-the-clock monitoring continues, modeled after axial seamount's proven system, but the root cause is still unconfirmed. What lies beneath this California beach, a hidden fault, a sleeping volcano, or something else, remains unsolved. For now, the records show only this. The coast is changing, and the next chapter will be written by what the sensors reveal.